Hello YouTube, James Green, Short Series Shenanigans. So, we'd like to thank Dennis Nolan at Niagara and Seco Tooling. Again, I'm sure you guys have probably seen all the videos from the fellow YouTube contributors that are out there. The very, very generous, gracious donation. You know, we as YouTube contributors, we don't do it for the money on it. I mean, people think, oh, you make money at YouTube. That's not a whole lot, trust me. But, you know, what it is, it's a chance, and it's humbling. It really, really is, for a company like that to look, and you guys see all the contributors that were involved in receiving it. It was a chance for the company to kind of pay it back into those of us that are helping, in a sense, I guess, maybe train the next generation. Not really. You know, well, actually, really it is. You know, keeping the craft alive. And everybody learns in a different way. That's why I'm always saying in my videos, this is just how I do it. You know, everybody has their own method to the madness. And so, thank you again, Dennis Nolan and Seco Tooling. So, we're at a standstill on the bolt gun build, and I'll kind of give you guys a little update. So, here's the bolt knob, or correction, not knob, the handle that goes on the bolt. Now, I was changing the bolt internals. I've already got, because we changed from this factory, we put on a fluted bolt housing, okay? So, you actually pull a screw and this comes off. What I was prepping this for, because I don't remember if I've showed you guys or not, I've made these bolt handles. Let me turn the camera down here just a bit. So I made these out of 304 stainless, and there's two different ones, and I keep them wrapped up so they don't get scratched up. So here we are. Here's two of them, and I've showed pictures of these up on social media, on Instagram and probably Machining YouTube. They're threaded 7/16 20, and I created that. And basically I just used instead of knurling, because we want it to be able to slide smoothly and ease of cleanup. For those of you that are familiar with, anytime you take a gun out on the range or grease or whatever, it's a pain in the butt to get garbage out of diamond crossed knurls. Straight knurls are easier because you can just take your brush and brush it straight out, but cross-hatch knurling, trying to get it out of a weapon, that's why you see most newer stuff that guys actually know and have experienced. You got to make it easy to wipe up, easy to clean, or especially if you're using it a lot, cross-hatch knurling can be really, really rough on your hands. So I chose to make these smooth, and what I actually used a grooving tool that was designed to create an internal O-ring groove, and I just mounted it up and I just created some shallow grooves here, nothing specific. I did try to space them equally apart, you know, start in to give it some symmetry. That's just kind of a standard round one. This one I tried to make it look a little bit like a cannon, just because a different style, and I chose to put this one right at the break where it transitions down onto its angle. So, you know, just a little unique design there. And so anyway, so this, back to this, I've got it covered, is actually a cast steel item. You can see the little, I'll get the light, you can see the little ports right there for the sprues, you know, where it was cast into the mold. So I've done a lot of these before. You put them in, and straight is relative, okay? You're turning it down, and all of a sudden my insert blows out. Boom, there was a hollow in there. So that put an end to that. Every once in a while on cast items, I mean, you don't know, because we were going to turn this down to 7/16, and I was going to, you know, turn all this, but first I get it all worked up, because I actually, I set this up in a 3-jaw, and it's pretty easy, but it went ahead and grenaded before I could get everything down to size and profiled in. But there was a hollow in there and it blew the insert out. So full stop on that. What I did, we got on the internet and, pardon me, got on the internet and found someone that is making these with a threaded on knob already. Now their knob I'm not going to use because it's got cross hatch knurls and rubber O-rings, and people say, well, you need that for a grip. No, it's, trust me, speaking from personal experience, anytime you start adding cross hatch knurl, it looks cool, but if you're using it a lot, it's hard on the hands, or it tears up your, let's say you have some really nice shooter's gloves and they're really thin and they give you a good sense of feel, okay? Having that really aggressive crosshatch knurling can tear up your gloves. I mean, there's really no need for it, especially on this. This is a bench gun, so we've got that coming. It's already, you know, straight, and I don't know what thread it is. It looks like 3/8/16, and if that's the case, then we're going to have to modify the thread to fit this. Probably what I'll do is I will create to redo this to make it simple. Create not a bolt but a stud, thread it in there, Loctite it, let it dry, and then re-drill if I need to. If it's smaller, if it's a smaller thread than this. So we'll see. I don't know what it is. It might be even 5/16, and if that's the case, then we'll just create a thread insert, and then we'll re-drill and re-tap, and we'll use permanent Loctite. And that's how I've fixed things like that before, but we'll see once we get it. So yeah, that is the first one of those that I have, because I've turned a lot of these down like that to create a thread on, or even, you know, thread it and then weld it or whatever to turn it down to your diameter. Again, because you're just getting relatively straight here, you can see with the axis. But so yeah, that was the showstopper. So we're at a stop on that for right now. Let me go ahead and put these back up, and I keep them wrapped in a nice little blue towel here so they don't get all messed up for the project. Slide them back in the drawer here. So what we're working on, and this is all a chance to use some of the Niagara cutters they sent us. Now I've got several pieces of 6061 aluminum T6. All right, I'm gonna mill them down, and I'm gonna use this milling cutter here that Niagara sent me. Okay, this is gonna be the one that I'm gonna be using. There's the nomenclature on it. All right, so it's a 3/4 4 flute high-speed steel insert. Now I started on this the other day and was filming and had issue with I actually had one of the leg wires come loose on the back of the mill in the junction box, because when I got this mill, whoever had it before, when they put the wires together, they wire nutted them, and I just got it up and got it running, and I've had issue on and off, so I stopped. I soldered all that so it doesn't come undone. So it freaked me out for a little bit. I thought my phase converter, what's going on? It was a leg that had come loose. So I got in there, soldered them up, put the wire nut back on, taped it, secured it, put it back in the junction box, so we're good to go for right now. So basically I'm going to move the camera over here. I'll try to get the light adjusted so you can see what we got going on, and trying not to wash everything out. Turn that back a little bit, and I've got this so I can have a little bit of light there. Okay, so what we're going to be doing is I have, these are 1/2 inch plate 6061 aluminum. They're actually just over 6 inches long. Now the bottom and the back side over there were actually cut with a coal saw, so they're straight. They're actually 90 degrees to each other. What is not 90 degrees is this side and here. So we're actually going to mill these down to where they're approximately 5.5 inches by 5.5, because I'm going to make some fixture plates, and that's something I've been needing to do. So this is a filler project while I'm waiting on other stuff to show up to be able to get things done. So we've already got it chucked up here. We started using this the other day when we had yesterday when we had the, oh no, what happened to the mill pucker moment. So we're going to be running 660 RPM, and I've got the clamp on here just to make sure nothing spreads or lifts. Extra clamping power. So we're going to come up here, we're going to get started. Come back to this other side where it was so I can get my original depth. Because I'd already started this the other day when it was the oh no, what happened moment. So I'm going to come over here, touch off where I was on my height. There we go. I'm just going to eyeball this. This isn't critical. It's not a super critical height or anything. All right, here we go. Give everything a little bit WD-40 there. Forgot I had that wrench sitting up there. All right. So where we've got our, because there's no like inch per minute or whatever on my power feed here, it's setting about 2.5 on the feed. So that's the feed rate, which there's nothing in the book that I got with this that shows this is how many feet per minute. You guys can see the handle at the ends down there when it's moving. But we'll go ahead and continue on and we'll let her fly. Now for those of you that are curious, we're running about a 1/2 inch depth of cut, and I did speed it up a little bit, and I cut back down to like 2.5 on here. I tried speeding it up a little bit on the back side, but you guys can get a good idea that run machines all the time about what the feed rate is pretty quick, and you can see how fast the handle is turning at the back. We'll go ahead and continue on. Go. Now, we're not too concerned about tool marks right now. You know, you can see obviously, and you could hear it with the chatter marks. What we're trying to do is get this down to a dimension here, because these jaws only open to right at 6 inches, and I want these plates, I'm going to make them 5.5. So to come back, if I was worried about tool marks or whatever, and everything is relatively flat, I mean there's a little bit right here, but what we'll do is once I get this in dimension where they'll fit down in here, we'll set standoff, or not standoffs, parallels, and then we'll come in, and these will actually be laying on the side, and I'll come in and we'll side mill, and we'll really dress everything up. So we've got that. Let me go ahead and, because now we're going to actually rotate all this. Let me get a little air in here. That. All right, over here, and we're just going to rotate this is what we're going to do. Now, as we said before, this and this were already cut very well, or correction, this side and this side were cut with a saw already, so they're actually 90 degrees to each other, and I lined them all up. So this is the other side, and we're already set to depth, so there's no adjustment required. We just flop it over and wash, rinse, and repeat. Now I got the garage door open. You can see where it's washing out, so we can kind of keep down on the smoke a little bit. So hopefully it's not washing the camera out too bad or anything. Let's see. sure that's not, yeah. I'm gonna poke that back that way a little bit. Trying to get you guys where you have a good view. All right, we're gonna come in here. I'm gonna zoom you in a little bit so you guys can get a good view of what's going on. Do like I did last time. We'll start here on the back. And I'm running about half the width of the end mill here, approximately. And all right, I'm gonna go ahead and zoom you guys in, and we'll go ahead and get started. Really pushing the end mill here. Now there we're about 3/4 of the thickness of the end mill. I want to go ahead and push it. Okay, we're up at the number 3 on the power feed here. Now this is hand, when I feed it back on the Y, I'm hand feeding it. Same thing, and go. Performing very, very, very well. Now we're about 3/4 of the width of the end mill approximately. That's almost too much. Back it down. Out a little bit. There we go. Slowed it down to about 2.5. We went ahead and slowed the feed down to about 2.5 on the power feed. Pretty quiet right there because it's only the material left is just above one piece of material. So when you have the others that were kind of like vibrating together, creating a pretty good chip right there. Real smooth finish. Real big chip. And we're almost done. let you guys zoom in there a little, or actually I'll zoom you in a little bit and you can see the diameter of the chips there, or the dimensions. Really, really, really big. Okay, those are, let's get one and see. I mean, those are some, I was really, really pushing it. You can see where we slowed it down here. Let me go and back the camera out. And you can see the chip is, we're approximately, and this is just an average of 130 thou approximately width of the chips, and that's relative. You guys know that do this all the time. I don't know what the feed rate is on this because there's no, this correlates to so many inches per minute or feet per minute on this power feed, but that's why I was calling out the numbers for those of you that do have similar ones. Let me go ahead and close the garage door so it'll not blow it out. There you go. Really pushing it. We were 1.5 inch depth of cut. Again, this was the end mill that we were using for the Niagara cutters, and we're creating, and I'm going to be doing some more videos, and I'm actually going to be setting up my tapping head. I've got aluminum everywhere. I'm going to have to pull up the vacuum and start vacuuming. So there you go. This was showing one of the cutter tools that I got from Niagara Tools, flying razor blades. So yeah, having a vacuum handy near the mill is a must. And so I made the mistake of, I went and grabbed some, moved them over, and I was sitting there pulling razor blades out of my hands. So this is definitely get the vacuum out and vacuum up. So there you go. There's going to be more videos. This is video number 1 of creating a, or we're going to make 4 of them actually, fixture plates. And I'm only going to show the basic highlights. I'm going to show you my tapping head and drilling and stuff that I've got. It's an old Enco. It's pretty neat, so I know I haven't showed that, so you're going to see that. But now we've got it down to a basic size where I can get it in my vise and edge mill and get everything to, you get rid of the tool marks and make sure everything is really nice and true and straight. And so there you go. Thank you again, Dennis Nolan, Niagara Tools, Seco Tools. I've got some projects over here where I'm going to be using those inserts on the lathe, and you guys will see that on video. So stay tuned for the next video. We're going to get everything ready, and we'll do on the next step. So there you go. Thank you, thank you, thank you guys. Don't forget, Bar Z Summer Bash 2016 coming up. You guys, hit stand up. Slots are filling up fast. So there you go. Look forward to seeing you guys there. I'm taking lots of neat tooling to buy, sell, trade, and swap, and all that good stuff. So until next video, take care of yourself and take care of your family, because remember, at the end of the day, you and your family is all you got. Be safe, get out in the shop, make some chips, man. This is cool stuff. Talk to you later, bye.